So to summarize, we have this pyramid that represents the memory hierarchy, where you get closer to the registers, you have very fast memory, but there's very little of it, so it's small. And as you go down, you get a larger and larger cache and eventually the main memory. So here it is large, but the price you pay for that is that accessing the data gets slower and slower. Okay. So how large are these various parts of the memory hierarchy? Well, we saw that we had 16 vector registers, each of which could store 4 doubles. Okay. The L1 cache on the kind of CPU we target is 32 kilobytes. The L2 cache is 256 kilobytes. The L3 cache is 8 megabytes. And then main memory, well, that sort of depends on how much you spend on your laptop or your computer, but well, it's pretty typical to have, say, 16 gigabytes of main memory. So you may ask yourself, how big of a matrix actually fits in the different layers? And for that we have a little exercise for you to do. And the important thing to keep in mind is that kilobytes means 1024 bytes. A megabyte means 1024 kilobytes, so that means 1024 squared bytes. Gigabyte is 1024 times that, 1024 megabytes. And the other thing to keep in mind is that it takes 8 bytes to store a double precision floating point number. Right, so go do the exercise.